Some special cases of binomial distribution involves one of the distribution as binomial distribution. Before discussing this, let's understand what is a Bernoulli trial. Bernoulli trial is a trial in an experiment where each trial has exactly two outcomes, that is success and failure, and probability of success remains the same in each of the trial. In this trial, such a trial is termed as the Bernoulli trial. Now, such a trial exactly is dichotomous in nature, means it involves only two outcomes, success and failure. We can take an example, suppose tossing of a coin in which success is getting a head. And if such an experiment is repeated n number of times, obviously getting a head every time has the same probability, that is 1 by 2. The case of a dice when it is rolled and success is defined as, let us say, getting a 6. So repeating such a trial n number of times, getting a success will have fixed probability 1 by 6 and having a failure have the fixed probability 5 by 6. So such a trial is also Bernoulli in nature. Now a distribution involving Bernoulli trial when repeated n number of times, then the distribution is binomial distribution. So this distribution is binomial distribution. Binomial distribution have two properties. The probability of success is defined as P and it is always constant for every trial. And then we can define Q, which is equals to 1 minus P, as probability of failure in that experiment. So if the experiment is repeated n number of times, then getting R success out of n trials has a probability which can be defined by this formula, NCR times P raised to power R into Q raised to power n minus R. Some textbooks also list it as NCR P raised to power R and 1 minus P raised to power n minus R. This can be the rth term of the expansion of this distribution Q plus P raised to power n. So because this rth term is obtained by binomial expansion, that is why such a trial is also known as binomial distribution. In some cases, NCR is written as this. So the probability of R success in some of the textbook may also be found to be written like that. So this is in fact combination of n with R and P raised to power R times 1 minus P raised to power n minus R. The mean of binomial distribution, mean, that is also known as expectation, mean or expectation of a binomial distribution, can be represented as Ex, which is same as mu. It is equals to n into P. It can be verified by some mathematical properties, and the variance of the binomial distribution, which is variance of can be said as variance of x, is actually npq. So standard deviation of binomial distribution is always square root of npq. So if x is a random variable x, if it follows binomial distribution, then it is written as x follows b with parameter n and p, where n is the number of trial and p is the probability of success. It is sufficient to write it like Now let's discuss some examples of binomial distribution. So let's have this as our first example. A dice is thrown 6 times and getting six times and getting one is considered a success. Find the probability of getting, and there are three parts: exactly one success, at most one success, or at least three success. We also have to find the mean and the variance. So first of all, let's define the probability of success. Because getting one is considered success, so probability is 1 by 6, and then q, which is 1 minus p, will be 5 by 6 in this case. Now n is 6 because it is repeated 6 number of times. So now probability of getting exactly one success, which may also be written as just p1, it will be 6c1 into p raised to power 1 and q raised to power n minus 1, that is 6 minus 1, which is 5. 6c1 is 6 factorial over the difference, that is 5 factorial and 1 factorial. P is 1 by 6, it's raised to power 1, and 5 by 6 raised to power 5. So the answer comes out to be 6 into 5 raised to power 5 over 6 raised to power 6, or simply 5 by 6 raised to power 5. It can be further simplified by the way, but we can leave it here. Now the second case is at most one success. So it means getting less than or equal to one success. So it is the case of getting a zero success or one success. Just like we calculated the case of one success, first of all calculate the case of zero and then one success. So probability of zero success can be written like this: 6c0 p raised to power 0 q raised to power 6. And that of one success, it should be 6c1 p raised to power 1 q raised to power 5. 6c0 is 1 and 6c1 is 6. So the answer is q raised to power 6 plus 6 times p q raised to power 5. Q raised to 5 can be taken common. So we are left with Q plus 6 times P. Now the values may be inserted. So it will become 5 by 6 raised to 5 times 5 by 6 plus 6 into 1 by 6. So finally the answer can be 6 by 5 by 6 raised to power 5 into 5 by 6 plus 1, which is 11 by 6. So the answer may be 11 by 6 into 5 by 6 raised to power 5. We can also leave this question here. Now, at least 3 success out of 6 trials. So, at least 3 means getting less than or equal to 3 success. So here we have to find the probability of 0 success, probability of 1 success, probability of 2 success, and probability of 3 success. Alternately, we can also write it as 1 minus probability of 4 success plus probability of 5 success and probability of 6 success. It is subtracted, this sum P4 plus P5 plus P6 is subtracted from 1 will be giving us the same answer. It can be easily calculated using the same formula. So the required probability will be 6C0 p raised to power 0 q raised to power 6 plus 6c1 p raised to power 1 q raised to power 5 plus 6c2 p raised to power 2 q raised to power 4 plus 6c3 p raised to power 3 q raised to power 3. So because it was at most 3 success, so this particular summation will give us the correct answer, or it would be 6 raised to power q raised to power 6 plus p q raised to power 5 plus p square q raised to power 4. Sorry, there should be a coefficient 6, and here the coefficient should be 15, and 6c3, the coefficient comes out to be 20, and pq qq. On simplification, inserting each value, we can get the required probability. Now the second part of this question asks us to calculate the mean. As we discussed, the mean of binomial distribution is n into p. So n here is 6 and p is 1 over 6. So mean is 1. We are also asked the variance of this distribution, and the variance of binomial distribution is always npq. So the answer should be 6 into 1 by 6 into 5 by 6. And eventually the answer is going to be 5 over 6. Let's have another example. Suppose the question is this, that the probability of LED bulb manufactured by a factory will fuse after 365 days is 0.05. We have to find the probability that 10 out of 10 such bulbs, none or more than one or all bulbs will fuse after a year's use. So clearly the probability of success is that the bulb will fuse, which is 0.05, and probability of failure then 1 minus p, which is 0.95. Now the trial is repeated 10 number of times, so n is 10. In case 1, the probability that none of the bulb will fuse after 1 year's use, so probability of 0 fuse. So this answer should be 10c0, p raised to power 0 and q raised to power 10. The difference between 10 and 0. 10c0 is 1, p raised to power 0 is also 1. So the answer is 0.95 raised to power 10 eventually. This can be calculated using a simple calculator, or you can leave it like that as well. The second case is that more than one bulb will fuse. So probability of more than one failure. It can be find like that, 1 minus probability of less than or equal to one failure, that is the negation of probability of more than one failure, because it is easier to find. So this one will be probability of 0 failure, 0 success, 0 fuse of bulb, and probability of 1 success. So that is one of the bulb will fuse. So the answer should be 1 minus 10c0 and p raised to power 0, q raised to power 10, or and minus 10c1, p raised to power 1, q raised to power 9. So it should be 1 minus, as we calculated this probability, it is 0.95 raised to power 10, and the second one will be 10 into 0.05 into 0.95 raised to power 9. For the sake of simplicity, we can leave this answer right here. The third part is that all of the bulbs will fuse, means all 10 will fuse after a year's use. So here R is 10, so the answer should be 10C 10, P raised to power 10 and Q raised to power 0. 10C 10 is 1, so the answer is just P raised to power 10, or 0.05 raised to power 10. We have to also find the mean. Mean is, as discussed, has a formula n into p. N is 10 and p is 0.05, so the answer is going to be 10 times 0.05 or 0.5. Now the variance has formula npq, so it should be 10 into 0.05 into 0.95, which will be 0.475.